So what I'm going to do is that board work, I request you to please use your pen and paper. Right. If you use your pen and paper, believe me, maybe in next 1 hour, we will finish things. If you don't use your pen and paper, we anyways finish maybe 1.5 hour, but your understanding may be even more firm if you use your pen and paper. Just zibble, or what you say, just keep on writing whatever I am writing. That just assume that I'm in front of you, and whiteboard or green board is in front of you, and on that I am writing, and whatever I'm writing, whatever interests you, in fact, you please keep on writing most of the things, because I'm only going to write the important things. Yes. So interesting. Why is it interesting? Because NLP is equivalent to transformer. It's not a very big sentence, by the way. NLP equivalent to transformer is the reality right now. Somebody will argue with me, I may justify, he may give points, but assume that more or less complete whole big area, which is a very, very interesting and a big area itself, but I guess that almost each and everything can actually be done using transformer. And that's the most important thing, that transformers are not very complex to understand. They are, in fact, they if you read the papers where they have given that stuff, it was complex, but I will try to explain it in the very simplest possible way, and later details and so many other things must be there. So for that I will give you again certain links and this and that. Yeah, so it all started with the paper by, I assume, Vaswani. Name may be slightly incorrect, but I guess it is the correct name. But the paper was Attention is All You Need. By the way, landmark paper, we need to be very happy that this is actually a landmark paper, maybe in 17 or 18, I forget, 18, something like that. They have said that only attention is something that you are required if you are working in the case of natural language processing, and their model was something like Encoder. And I am going to take this specific task of language to language generation. I am good. And then I am having some representation. You can write that representation also over here. You can also write representation like this. And then the coder got that representation, and somehow by magic started to convert it into, I'm using some text. I don't know, is this the French language or which language? Maybe, I assume that's the French, if it is French. Yes, that's the French. So English to French, it's converting. One good thing, let me write it directly over here. This and this. If you see it, finally it will be converted into bird. And this is GPT 2, 3, whatever, that was generative. So that is, by the way, its full name is BERT. Its full name is bidirectional. Bidirectional, what is the full name? I also don't remember. Bidirectional, somebody can Google in between and tell.
Encoder representation from transformers.
Yeah, representation from transformer. Same for GPT, I again forget. Generalized pre-training, I guess. Generalized pre-training from, again, maybe transformers. So before going to talk anything other than this, other complex things, transformer is having an encoder which will take input from source language, have a decoder which will take the representation learned by the encoders and convert them into that target language. This thing can actually be said as, this thing can be, so it can be said as GPT, the decoder, and the encoder is actually being said as the BERT, bidirectional encoder representation, the generalized transformers. Okay, these are two things we understood.
Sir, how
Any
it is
questions?
different from autoencoders? Like one thing is that it works on sequences. What are other differences?
Yeah, that's true. First thing is that it's actually an encoder decoder architecture using the in between, encoder and decoder in a different way. Anyways, it's actually a auto encoder, but it's not an auto encoder. You can say it's actually an encoder decoder representation, because whatever it is taking, the same thing it is not generating. So it is the encoder decoder. Anyways, it's written that it's an encoder and decoder, but not an auto encoder. Yes, no?
Right, sir. Right.
Right. Yeah.
What
The
is
only thing is that what is?
GPT 3 is some version, huh?
Yeah, 3 is the
GPT-3.
version. Yes. 1, 2, 3, and so on.
Okay.
So GPT-3 is actually a bigger or a deeper version with more and more layers. Okay, good. So let us give you one by one simple things, and let us see that if we can understand it. Yes. So I have English going into French. Now English is like, E1, E2, E3, and so on, and EK. So English word, English sentence is having K words that are being fed. And your French is going to have maybe F1, F2, maybe FL words. So both of them are going to have, different words, the same meaning. I wanted to go, मैं जाना चाहता हूँ. So source and target are going to have different number of words, even though conveying the same exact meaning. Our this network encoder. So encoder is going to see English, decoder is going to give you the corresponding French. An encoder is actually learning self-attention. What is that? I will let you know. And decoder is learning not only the self-attention, but the cross-attention as well. Self-attention as well as the cross-attention. Yeah, both of these things. Okay. What is self-attention? What is cross-attention? We will come back. In fact, it is. So I will come back to it. Please remember, if I forget, I will come back to it. Okay. So we will first open or understand encoder. And once we understand encoder completely, decoder is just the replica of that, with one small or one more thing, as you can always see, that encoder is only doing self-attention. Decoder is doing self-attention as well as cross-attention. Once we understand self-attention, then cross-attention is directly understood. So from here to here we will come. So first we understand encoder, then we understand decoder. Within encoder, if we understood each and everything, decoder is only doing the cross-attention more. And once you understand self-attention, you can directly generalize it to the cross-attention, which essentially means that if we are done with encoder, we are almost done with decoder. Very few simple things remaining. Okay, so let me show you an example of our encoder that when I am good. 3 tokens, token number 1, you can say token number 2 and token number 3. They all go into my encoder. So if I say encoder, it is not, so completely it's a single encoder, but having same repetitive few layers that we used to call it as encoder 1, encoder 2, encoder 3. Same block repeated again and again. How many? N times. And this is your encoder block. Top level architecture says that you have certain layers like this. What are they? We'll talk about. But keep on stacking them one over the other. How many such things? N such thing. The value of N is equal to 6 actually for initial transformer network, and then they keep on increasing. So once you come up with a network and then you keep on increasing to its limits so as to get the best possible performances. But for attention is all what you need is actually a transformer which is having an encoder and a decoder. Encoder is having 6 such encoding stuff. What are they? We will talk about that.
So each E1, E2, E3 are layers, sir?
They are blocks having multiple layers.
Blocks of multiple layers. What is N equal to 6? 6 number of blocks.
Yes.
Okay.
Yes. So yes. So once we understood, let us talk about any EI block. This EI block is like this. It is having MHA and FFN. What is this? This is multi-head attention. And what is this? This is feed forward network. How many students have joined, by the way? Let me see. 25 at least. Out of that, one is the Daksh. Okay. Yeah, so they're going to miss a very important topic. Maybe they can refer to our lecture video. Yes. So there are 2 things, by the way. I'm going to explore or open things one by one. And this is, we understood that individual encoder is something like this, and this having 2 stuff. And one encoder is having so many encoders, stack of encoders, and one encoder is actually having these 2 things. If we understand both of them, we are done. Feed forward, we all anyways know. We need to somehow understand multi-head attention. Yeah, so let's start. Some small